Antje and I have spent the last year giving up holidays, weekends, nights, evenings, forgetting about our families temporarily. We've since restored our relationships with our families, but we wanted to do this to bring to everyone the awesomeness of SageMaker. Let me find the little chat thing here. So let me post this in the chat. And that's a link to the book. That's also a link. This Saturday, we'll be doing a public workshop. We've got it down to about 4 hours. So I think the invite still says a full day. This is actually just a half day. So we're going to give it a run. This is our first time doing a lot of brand new material. So check that out. Actually, quite a lot of what we cover in the book. The book goes into much more detail, but the workshop is a nice hands-on application of that. We also have the meetups here, which some of you probably came through here from, and the code. So this is all of our code here. And then, of course, YouTube videos and all that fun stuff. Check out the YouTube channel. So the book, you can get to that link here. Let me post it. This is actually for pre-sale right now. Looks like I'm posting into the wrong thing here. That's the website I was just showing, and then here's the book. So pre-order. I believe this is scheduled to be released in April. So perfect Easter gift for you and your families. Okay, and Antje, you had a quick announcement too, right, about Innovate conference coming up?
Yes, so let me quickly grab the screen share, just 1 minute. And give you a quick heads up. So Chris and I had the pleasure to work with the AWS Innovate conference for AI/ML. So on February 24th, we do have a dedicated AWS online conference coming up that's showing all of the new innovations, all the new services and features that we launched from reInvent, specifically in the area of AI/ML. It's for free, so you can register online. It's taking place on February 24th. We have experts joining for the day, so you can have Ask the Experts live. We do have a lot of customer stories that tell their use cases and a lot more. So it's really one day full of technical and demos, use cases, etc. And the good news is it's happening around the different regions. So if you're joining from the Americas, and I'll put in the links here in a bit, we have made sure to be as inclusive as possible. So we're running across the different time zones here. We also do have different language support. So here you can see the Innovate Americas hours on February 24th, also in French, Portuguese, and Spanish language tracks. And the agenda is really full of technical sessions. So we do have this level 100 to 400 categories, and level 400 is really kind of the deep dive expert level. 300 a little bit lighter, and then the 100 and 200 are kind of introductory sessions. So there's a little bit for everyone in the conference. And you can see here different tracks really from talking about how you can accelerate your AI/ML journey to a full dedicated track to listening to practical use cases, or to experience all of the new AI/ML features that got launched at the last reInvent conference, and also dedicated tracks for startups, for ISVs, etc. So really a lot of good sessions in here, and Chris and I have worked to put together the technical agendas. So we hope everyone has something in here. Also, me particularly, I've worked with the European team. I'm based in Düsseldorf, Germany. So I've been working with the EMEA team here. And again, all happening on the same day. But we do have slight adjustments here. So the EMEA conference, for example, we will have, of course, also local language tracks. So we cover French, German, Hebrew, Italian, Russian, and Spanish. Myself, I'm presenting in the German track, 2 sessions, and also in the main English track. And we have put together a similar agenda. We've kind of sliced the different sessions here into different job role persona types. So if you're an application developer and you might have a little bit less background in AI/ML, there's a dedicated track that shows how you can use some of the AI services that are really just an API call away to embed smart functionalities into your applications, AI-driven functionality. And then also we do have the tracks if you're a data scientist or a data engineer. Also, if you're an MLOps engineer and want to focus on building platforms and automating. And also we do have expert talks. So we're interviewing some of our community members, machine learning heroes, and have them share exciting use cases, what they've been working on. And also, if you're joining, I think my PowerPoint just crashed. Sorry for that. Also, if you're joining from the APAC region, we also do have tracks there. So we're also covering the different regions and also a very exciting agenda similar to the Americas one. So that's just really as a quick heads up. It's happening online, free to register if you're interested in tuning in. And just one more last plug. If we have European people joining today here, the webinar, in the German track, and if you speak German, we do have the Bundesliga speaking. We just recently launched new match facts powered by AWS. So real-time statistics out of the European football league. So when they're playing, we have some advanced statistics that get calculated, and they will talk about how they implemented that. So in case we do have some German attendees here today, that might be an interesting session for you to join. All right, and let me see, I'll put in here the links where you can sign up again for free if you're interested. And with that, I'm handing back over to Chris and introduce our first speaker.
Awesome. Yeah, so let's see, this looks like Innovate is in 8 days, right? This is coming up. Wow.
Yeah.
It's funny when you spend so much time like setting up the agenda and then all of a sudden you're like, oh wait, this is actually happening. So I should also mention that today's 2 talks are not actually part of that conference. So you'll be hearing brand new material and material that will not even air at that conference, at like the Innovate conference. So super excited today, especially we've got one topic that me and Ansha have been pretty passionate about. We cover this in our book, this concept of a feature store. And Mani, are you going first or was Heiko going to go first?
Hi, Chris, I'll go first.
Okay. Yeah, so Mani, can you give a quick intro, how long you've been with AWS and tell us what you focus on and just get right at it.
Yes, thank you so much, Chris. As Chris has already introduced my name, so I'm Mani Kanuja, and I work as an artificial intelligence and machine learning specialist at AWS. I've been working with AWS for about 1.5 years now, and I really help my customers, mostly in manufacturing and retail industries, on their machine learning use case and how they can use AWS machine learning tech stack to solve their business use cases. So that's what I do. And today I'll be delivering a deep dive on Amazon SageMaker Feature Store. So let me share my screen quickly over here. So I hope everyone can see my screen now. Okay. Yes. Thank you, NJ, for confirming it. So we'll be doing a deep dive on the feature store. But before I do that, I would like to take a step back and think about if I have to solve a business use case using machine learning, what will be my first step? So my first step would be to collect that data and prepare that data to process it, right? And that's a really time-consuming and resource-intensive process because you might be having different teams who are working on the similar data and then for different machine learning problems, right? So it's more of a repetitive task, which uses a lot of resources. And as you can see on this slide, with the Forbes survey that was happened in 2016, 80% of the data scientists, they spend time doing feature engineering, or I would say data processing. Why this is important? Because the quality of your machine learning models really depend on the quality of your data, right? And so we need to transform that data before it can act as an input to deliver accurate machine learning models. And when we say that we need to transform our data to do that, we commonly refer to as features on that transformed data, right? So what if we can store those features of the process data, which can be used by other teams, so that we don't have to repeat the same process of feature engineering or data processing, which takes so many resources and time as well, right? So let's see what happens when teams decide to have feature stores. Basically, when we say feature store, we are storing the features in some location, right? Where our different teams can see it and discover it and use it. So now there might be certain challenges when our teams are deciding to do that. So few challenges might be, they might be updating the same features at the same time. So there might be a drift or with the features, or there can be duplication on those features, which will really slow down our development and deployment, right? Now to address these challenges, we have launched Amazon SageMaker Feature Store so that the different teams can store and discover and share those features, and so that they can reuse it. They don't have to really execute those processing jobs, which takes so long to do that. So let's see how Feature Store addresses some of the challenges that we just talked about. So before we talk about the challenges, let me introduce you with two topics on the slide. So we provide support for separate feature stores, two separate feature stores. One is the online feature store. The other one is the offline feature store. The online feature store is basically used for real-time predictions. So it's supposed to provide you high throughput writes and no millisecond latency reads, right? Now with offline feature store is primarily used for batch predictions and model training. So another point is, can I use my feature store in online mode or only offline mode or both, right? So you can do all of these. You can have a feature store only in online mode, or you can have a feature store which is only offline, or you can have a feature store which is online and offline both. And we'll show that in the demo as well. Now, as soon as I say that you can have, you can have a feature store which is online and offline both, you might say, what about the feature drift that you just talked about, right? So in order to address that and remove all the heavy lifting from you, as soon as you update the online feature store, any updates to that online feature store are synchronously updated to the offline feature store within less than 15 minutes because it provides read after write consistency. And not to mention the offline feature store is based on S3. So when we create that offline feature store, you need to provide that S3 path. And you'll see that in the demo. So let's see how this works in action. So this is just to visualize how the feature store works. You have that raw data, you do it for processing, ingest it into the central feature store. The data can come from streaming applications, or it can, you can have a batch ingestion of the data. And as depicted in this architecture or diagram, you have this online feature store that you can use for real-time as well as batch inference, offline for model training and the batch inference. So this is just to visualize how this really works. And now to put everything into perspective, let me share this example with you. So on this slide, what we see is an example. So for example, if you are an automobile insurance company and you have this app, whenever you have some vehicle damage, you click a picture of the vehicle, and then you, as soon as you click a picture using the app, behind the scenes, it might just go to the S3 bucket, and it triggers the model, which is a damage classification model. And the damage classification model will predict whether the vehicle is damaged or not, or whether the hood is damaged or fender is damaged, so on and so forth. And it will update your online feature store, right? And you might have other information as well, related information, your claims, your information about your customers, the policies that they are enrolled in. So what happens is when you update this online feature store, this vehicle loss endpoint can fetch the latest features, predict the claim value, and send it to both the customers and the adjusters app, right? And you can also have, different machine learning models like we have shown over here to do that. So this is an example on how you can use the online feature store for inference. And Heiko, my colleague, will go deep into the streaming feature transformations and with a use case. So I leave him up to that. The next point is really how we can use the feature store for model training, right? So once you have this offline feature store and the data in there, you can use Amazon Athena, which is our SQL query engine, using which you can write SQL type queries and do those queries on S3. It's based on the Presto, can work on petabyte scale of data. So you do that. So if you have this offline feature store, which I told you earlier is based off on S3 bucket, you can query using Amazon Athena, extract the data set, and use it for model training. And this is something that I'm going to show you in the demo also, how you can create a feature store in both online and offline mode. Use the offline feature store for training, very similar to this, extracting the data sets using the SQL queries. And we'll use the fraud detection use case for our demo. So let's see how all this works in action. So before I start with the demo itself, I would like to introduce you to the three terms that we need to understand, right? One is whenever we are going to start and create the feature store, so there are three terms that are important. One is the feature group. As the name suggests, you can, based on your business case, you can group the features as long as they follow the same schema. It's good, you're good to go. And the feature groups will consist of the metadata about the data that you'll be storing on the feature store. And it will also have a list of feature definitions. The second term is the feature definition itself. So what is a feature definition? It's more of a schema where you provide the name and the data type. And once you have your feature definition ready, you create the feature group. So your feature group will have a list of feature definitions. The next step is once the feature group is created, you want to ingest the data into your feature group. So you can ingest the data as records. So what is a record? You think of it as one row in a table. So in this example, the demo example, we'll be using CSV files. So you can think of a record as one row in the CSV file. So that's all you need to know before we begin with our demo on the fraud detection use case. So the objective is once you have that transaction data, you're able to detect whether it's a fraudulent transaction or not. And we'll be using two CSV files. One is the identity file, which will consist of the information about the user. The second one is the transaction file, which will have information, which will have data about a particular transaction, like transaction amount, credit card, or debit card. And we'll create two feature groups based on each CSV file. So having said that, let's see this stuff in action, right? So the first section is really you are setting up the feature store, like defining the SageMaker session, region, feature store runtime session, and SageMaker session. Nothing much going on here. And since I mentioned that in this demo, we'll be creating a feature store, we'll create both offline and online store. So, and since offline store is based on S3, then we need to provide the bucket name. So in this case, we are using the default bucket and specifying the prefix where my feature store will get created. So I have my bucket now. Let's move further, have the execution role. This is SageMaker business as usual. And before we really dive into our feature store, the first step would be to inspect our data. So as I mentioned, we are using two CSV files. Let's look how they look like. So we're just reading the CSV files over here, doing some kind of transformation like NA values and all. And after we are done with that, this is how our data looks like. This is my identity data. The transaction data looks good. Now let's talk about how we can ingest that data into a feature store. So as I mentioned, the first term that I introduced was feature groups. So first we have to create a feature group. So when we do the feature group and how you can create a feature group, there are two ways. Either you can use SDK, as I'm showing you over here, or you can create a feature group using point and click like this. So you can specify the feature group name, description, fill on those fields. So this will become really easy once we understand the intricacies that are required. And so I'm not going to show you how you can create a feature group using the UI, but I'll show you how you do it using the SDK. So once you understand how we are creating the feature store using the SDK, it will become this will become really easy because you just have to fill in those fields. So let's get back to our notebook. But I just wanted to show you that it's possible. You just don't have to create the stuff with SDK. You can also choose to create it using the UI. Okay, so having said that, so now if I have to create a feature group, the first thing is I have to provide the name. So this is just defining the name of the feature group. I want to define my feature group object. So I'm defining the feature group object by providing the name and the session information. Now, the next part is the feature group consists of the feature definition. So we need to load that definition before we actually create the feature group. So this section is doing just that. It's creating the feature definition, which I mentioned earlier is nothing but a schema. You provide a name and the data type. So we are just creating that feature definition over here and we load that definition. But two things are really important before I move forward. These two fields are really important. So once you have your feature group, you will ingest data, which will act as records, right? So remember records, a row in a table or a row in your CSV file. So once you have your data in the feature group, you would like to query that data. In order to query that data, you need some identifier for your row, right? For your record. So we call it as a record identifier. So it has to be some unique value. So in our case, we'll be using transaction ID, which is a unique value, and it's present in both our feature will be present in both our feature groups, which is the identity and the transaction feature group over here, right? Okay, so I think I would have to exit and log in again. It has become unresponsive. Sorry about that. So let me quickly log in again. Okay, so we were here on ingesting the data. Okay, sorry about that little hiccup. Okay, so this field, as I mentioned, is important when you are trying to query your data, which you store into the feature store, into the feature group, right? So in our case, we'll be using transaction ID. The other part is this field, event time. So it's nothing but a timestamp. So what happens when you ingest the data into your feature store, and you might update the different features and have different versions. So when you specify this event time, which is an important field over here, it provides a timestamp to your feature that you store. So why is it important? Because using that, you can basically do point-in-time queries on your feature groups that you create. So that's why these two are really important fields, the record identifier as well as the event time. Okay, so now having said that, let's load these feature definitions. So now we are ready to create our feature group, right? Because we have provided the feature group name, we have created a feature, we have defined the feature group object, we have loaded the feature definition into it. Now all we need to do is create it. Very simple. We'll use our create SDK API to do that. Provide an S3 location for your offline feature store, record identifier, event time feature name, as we defined earlier, the role. And in this case, since we are using both online and offline, so you have to specify this field, enable online store equal to true, so that you can have your feature store in both online and offline. So we are doing this for both identity feature group as well as transaction feature group. And this is basically just we are waiting for that feature group to get created. And once this feature group gets created, you can also see it on the UI over here. So I've already executed this notebook so that I don't have to do it during the demo. So now you can see this is the feature group, two feature groups that are created, the online and the offline store type. And when you click on that, see the metadata. That's what I mentioned. The feature group consists of the metadata as well as the feature definition, the name, and the data type, integral, fractional, or string. So you can see it over here, right? And you can also use the describe API to describe your feature store. Of course, you can do that. So we are using the
Annie?
describe. Yes.
Just quickly, someone in the chat asked whether you could increase your font size. So maybe if you could just zoom in your browser window, that usually should help.
Is that okay?
Yeah, I can see it fine. I hope everyone else also can see it. Yeah,
Okay.
perfect. Thanks.
Yeah. Okay. Thank you for that, for mentioning that, Chris. And so we are doing the describe for our identity feature group, as well as for the transaction feature group. Similar, we are just seeing the metadata and the feature definition. You can also list your feature groups that you have created so far. So let's scroll down and see. So you can use the list feature groups to see the list of feature groups that you have. So at the time when I executed, I have like 6 feature groups, so that's why it's showing it. So now you have the feature group ready. So we have seen how you can create a feature group, provide a name, definition, you can describe it, list it. Now we have to actually ingest the data into our feature group that we have created. So you can do it in 2 ways, using the ingest API, or you can do it using the put record API. So the ingest API is really when you have to ingest a lot of data together. Like in this case, we are using ingest because we have just created a feature group and we want to ingest the data that we have into the entire data that we have. So that's why I'm using the ingest one. But in case you just want to update, record by record, then you can use put record API to do that. And if you have like a really large amount of data, then it might take some time for the ingestion process. But the good part is that you can specify the multiple workers to do the job simultaneously, so it speeds up the process. So I'm ingesting the data into the identity feature group. Similarly, For the transaction one, you can see my event time timestamp added to it. Same thing for the transaction feature group. Okay. You can see that contains of all the information about the particular transaction. You can see that event time again added over here as well, which is good so that we can do point-in-time queries, right? Now, earlier I mentioned, now once we have this data into our feature group, we really would like to query that data, right? So using your record identifier, that's where it comes handy because we created the record identifier, which is a unique value, right? Using which it can identify the particular record in my feature group. So in our case, we used transaction ID. So I'm just providing one transaction ID to see, to get the values for that particular record. So I just do get record, provide the feature group name and the record identifier, and I can see my record as key value pairs. So you can see transaction date, transaction amount, the other fields associated with the transaction. So you can fetch those using the record identifier. So that's where it comes really handy, right? The second part is if you are planning to create a Hive table using from your feature store. So the SDK really provides a nice shortcut to do that functionality so that you can generate the Hive DLL. So it's just generating the Hive DLL, nice little shortcut to create your Hive tables if you choose to do that. So I'm just printing that out. Similarly, you can do it for your transaction feature group also. So that's nice and easy. Okay, so now we have data in our online feature store. So as I mentioned earlier during the presentation, so once you have the data in your online feature store, it get updated automatically. It will update the offline feature store, but it takes about 15 minutes or less than equal to 15 minutes to do that. So what we are doing over here is we are just waiting for that offline feature store to get populated. So I'm just waiting over here. This function is doing nothing but just waiting. So data is available in my offline feature store. So if you recall from the presentation, we talked about you have those feature stores. You can extract the data set using Amazon Athena, simple SQL queries, and create that data set, which can be used for your model training. So next, this is exactly what we are going to do. So far, we have created two feature groups based on each CSV file that we have, identity and the transaction file. We ingested the data. We made sure that the data is there in the offline and the online feature store. So now since we have our data in the offline feature store, now the next step is to build that training data set. That's what we are doing over here. We are using Athena queries, and you can specify that SQL string. In this case, we are joining the data from the two feature stores using the left join that will act as my data set, which I'll use for the training. And then I simply run that query. Now the results of the query are stored as a data frame, and I have this data frame. So let's see what this data frame really has. So it has joined the two tables based on the two feature stores based on the transaction ID. And now I can convert it to CSV file, store it on S3, and use it for my training. And that's exactly what I'm going to do. And before I do that, since for this particular fraud use case, fraud detection use case, I'll be using an XGBoost model, for which I have to make sure that I have my target column as the first column. So that's what I'm doing over here, just making it as a first column. Converting into a CSV, as I mentioned, upload to the S3 location. And now this will act as my training data. And now let's train and deploy the model. So since I'm using XGBoost, so I'm just fetching the training image for the XGBoost container. So image for the XGBoost container over here. Now my training image will have XGBoost container. This is just usual stuff. And I specify where my, after training, where my output artifacts will go into. So specifying the S3 location for that. I'm creating my estimator for training, providing the training image, the instance count and the type where my training will run, right? So I'm just defining that estimator with all those necessary parameters, setting up my hyperparameters, training input. Remember, we created that data set, updated, and uploaded it on S3. So that's where I'm providing my training input in that training data, which is nothing but an S3 path. Now I have specifying it over here, and then I use training .fit to start the training itself. And now we are using the objective metric as binary logistics. So it will basically, during the training, it will provide me with the training loss or the training errors. So that's what it is doing over here. And now my training job has been completed, right? So once the training is done, now I'll let's host that trained model into the Amazon SageMaker real-time hosted endpoint. And why am I doing that? Because I want to show you, once you deploy that model, how you can use your online feature store for the inference, right? So far what we have done, I'm just reiterating, is we have created 2 feature groups based on our 2 files. Then we loaded the feature definition into it. We ingested the data into our feature groups. We made sure that we can query that data. We made sure that once the data is there in the online feature store, it's propagating to the offline feature store. And then next, we extracted the data set by using Amazon Athena to query that data from our offline feature store, extracted the data set, used it for our training purpose. And now our training job is complete. So we'll be hosting it as an Amazon SageMaker real-time endpoint so that we can see how we can do the inference using our online feature store, right? Let's do that. Let's move to this last part over here, which is the real inference, right? So in this section, what I'm doing is I'm providing this transaction ID on which I want to do the inference, right? Because you need to provide the record identifier, and in our case is the transaction ID. So we do get feature value. So this is just a small function to fetch the feature records. Now I can also provide the fields that I'm interested in. So that's what I'm doing over here. So I have the data from transaction feature store. Similarly, I have the data from my identity feature store. I'm just, joining all these pieces so that I can have my data for the inference request, right? So now in this variable inference request, I have my data, which I can use for prediction. So I did that, and now simple, using the predictor.predict, I can do the prediction and it will give me the probability whether the particular transaction is fraudulent or not. So that's how you can use online feature store for your real-time inference. And you can also use it for the batch inference, as we mentioned earlier. So that's pretty much it. And then don't forget to clean the resources. So we are cleaning these resources over here, deleting the endpoint, deleting the feature stores that we just created. It's good to do that. Otherwise, you'll be charged for the resources. And the demo that I showed you over here is available in the SageMaker examples so that you can work with it, play with it, see things happening in action now that you understand what's going on and how it works. So that's pretty helpful. So that was it for my presentation. And now Heiko will talk more about how you can use the streaming data for your machine learning algorithms and how you can use feature store to do that, just that. So thank you, everyone. And over to you, Heiko.
Great. Thanks so much. Just a quick introduction. So my name is Heiko. I joined Amazon 4 years ago. but I've actually been quite recently only with AWS. So only for 6 months now. Before that, I was a data scientist in Amazon in the EU customer service. And yeah, that's me. Feature Store is, I haven't had, because I'm so new to AWS, I haven't had too many customer interactions yet, but almost all of them, once we had our reInvent last year in December, were super interested in Feature Store. And some of the reasons is, Mani already mentioned that, is like, you know, the sharing of features and the historical access. But the other one really is feature stores are essential when it comes to real-time predictions. And more companies and AWS customers want to do real-time, you know, want to deploy their machine learning models in a real-time scenario. So if you think, for example, about you know, a ride-sharing service. A ride-sharing service app will leverage a machine learning model under the hood, but in order to give you the correct price or the best price, they need to know, you know, the number of ride requests they received in the last 10 minutes. Similarly, if you look at, you know, an agent in a customer service, they get an incoming call. The best way to help the customers who call in customer services to know the customer's latest web session clicks. So these are all these real-time scenarios where
Hey, so Heiko, can you share
yeah.
your screen?
Oh,
yeah,
yes, I'm not sharing. Yeah,
cool.
Yes, sorry about that. Share screen. How's that? Can you see my screen?
No. I cannot. Oh, I think now I can. Yep.
Yeah.
And
you should see a GitHub repo.
Store. Yeah.
Yes.
Mm-hmm.
Excellent. So let me just quickly. Oh, where did my Zoom go? Chat. All right. So this is a GitHub repo we're going to be looking at, and basically what we're going to be doing here is we look at another example for fraud detection, but this time with a streaming aggregation architecture. So this is the architecture that we're going to be looking at. I'm going to walk you through this. And then the demo will be quite short because it actually consists of several notebooks, which we can't all go into, but I will show you the juiciest part of the demo. So first what we do is we have our training data, which consists of transactions and fraud labels. So I don't know if you guys can see my mouse when I scroll around here, but basically I start at the top left of this diagram. And then we do a processing job with PySpark, where we basically aggregate the data and save the data, A, in a online feature store, and B, in S3 for model training and deployment. And this batch aggregation will be done like, you can do that, for example, overnight, because all you do is you look at historical transactions and you calculate basically the number of transactions in the last week, the average amount that someone withdrew with their credit card or paid for with their credit card over the last week, and the transaction times. So that's the first part, and that's what we're going to train the model with. And then the second part is basically the lower half in this architecture. And this is now where the live transactions come in. So you can think of it like, you know, you're in a store and you pay something with your credit card. This live transaction then will be fed into a data stream. In our case, we're going to use Kinesis, AWS Kinesis. And then we're going to do some aggregations on that. So we are actually then interested, in order to predict fraud, we're interested, how many transactions did you do in the last 10 minutes? Because, you know, the assumption here is that, you know, if someone stole your credit card, they're going to do and try as many transactions as possible in a very short amount of time. So we want to actually detect this burst in transactions. So we're going to do some streaming aggregation here, where we basically figure out how many transactions were done in the last 10 minutes and what was the average amount of those transactions in the last 10 minutes, and then compare that to the spending pattern that we've detected from this credit card over the last week. So we basically are then able to figure out, or the model is then able to figure out, oh, there's something unusual happening here. I'm going to give this transactions a very high risk score when it then comes to detecting the fraud patterns. So once the aggregation is done, a Lambda function will push all the data into the online feature store. And then I mentioned that earlier in one of the questions. The online feature store has a very low millisecond latency for writing and reading data from that. And that's why we're going to use the online feature store in this example. So the data, once it is in the online feature store, we can retrieve it in the low milliseconds. And one statistic here, and I've shared that in the chat as well, is there's a P95 latency lower than 10 milliseconds for 15 kilobyte payload. So it is quite quick. So that means when the transaction comes in, on the one hand, we're going to aggregate the data and store it into the feature store. And then we're going to trigger another Lambda function, which basically retrieves the data from the feature store, calculates these ratios that I mentioned, how was your spending pattern in the last 10 minutes compared to your spending pattern in the last week. And then the fraud detection endpoint, so the model that we have trained with the training data, will be called and will return a risk score. And based on that risk score, we can then say, okay, we think this is a fraudulent transaction or not. Any questions so far? Feel like I'm talking very fast.
We do have a question here. Yeah, Heiko, if you could define the P95 latency a little bit more.
95% of all the requests that the online feature store gets, which are 15 kilobytes or lower payload, will be answered in 10 milliseconds or less. Does that make sense? I hope this is right. But
yeah, the way I always think about this is it's no longer good enough to just say something happens in 100 milliseconds or 200 milliseconds. Like at scale, I saw this when I was with Netflix for the first time, really, like about 10 years ago, which was people didn't just quote a single number. You would always quote a number with its P90, P95, because once you get up to P99 or P100, there's really, yes, that number is going to be up in the seconds in some cases, right?
Yeah.
And I'm just kind of making things up right now, but you like always want to define P something. And yeah, just like you said, 95% of these requests happen in that amount or less.
Yeah, the P just stands for probably probability. So percentile, probably percentile.
Right?
Yeah, something like that. Anyway, back to the demo. As I mentioned, it's 6 notebooks actually that were run here. I've run them all already. We are in the 4th in the 5th, because it starts numbering with 0. So we're in the 5th notebook just before cleanup. And what has happened so far is we generated a synthetic data set. We created 2 feature groups. Then we did the processing with a PySpark processing job in order to create the training data set. And then in notebook 3, we trained an XGBoost model to detect fraud. And now we're in notebook 4, where we simulate the online transaction, the online scenario. So what we're going to be doing here is we're going to feed some transactions into the Kinesis data stream. and the data stream will pick it up and will do all the rest for us. So the data stream will aggregate the features, call a Lambda function, put the features into the feature store, and then another Lambda function will retrieve the features and call the model to see if, you know, the transaction was fraudulent. And yeah, as I mentioned, it's on GitHub, so you can download it and play around with it. I'm going to go now to the part where we're actually going to send these transactions into the Kinesis data stream and see the results. So I'm going to execute this cell here. And basically what it does is it first sends 3 transactions from separate credit cards, just to show you how a normal response or normal transaction looks like and how the model responds to normal transactions. And then we're going to simulate a fraudulent case where there's several transactions happening on the same credit card number. So within, you know, 8-9 seconds, there's going to be a transaction on the credit card number ending with 285, and then another one and another one. I think in total we're going to have 6 or 7. And then we want to look at, well, how does the model pick up on those patterns? Okay, so this is transaction number 5, which is actually number 6 because we start again always with 0. So this should be the last transaction that we're going to send into the stream. So now the model sees this pattern of, like, you know, 7 transactions were sent with the same credit card. So the results obviously can be stored, you know, somewhere in S3, for example, and then you can visualize them in QuickSight. But for this purpose, it's just the easiest to go into CloudWatch, where we can see the model responses right away. So if I double click on this one, and oh, geez, how do I get this thing out of the way? Let me just single click on this. Yeah, there we go. So now we're going into CloudWatch. CloudWatch is basically a like the place in AWS where you collect all the logs from your AWS resources. Now we see these are the transactions that I've just sent. We start here at 5:52 UK time, and the last transaction was at 5:53. And now here is what the model has picked up. So the first transaction ending with 960, the card number, it detected it was not a fraud, and actually this is the risk score, which is super low. And then also for the second and the third credit card. Now we come into the realm where we send 7 different transactions for the same credit card. So the first one, the model is not obviously suspecting anything, but then, you know, you see here also it picks up on the number of transactions in the last 10 minutes. 7, that's not.
And just quick here, Heiko, could you zoom in a little bit as well?
Oh, yes, sorry. Yes.
That makes it easier to read. Thanks.
Yes, there we go. That should be fine. So, and then we start sending more and more transactions for this credit card number. And you can see how the risk score slowly goes up. And then once we hit, you know, 3 credit card transactions on the same credit card number within a few seconds time, suddenly the risk score now jumps from 7.1% to 61%. And then for the following transaction, it goes even higher to the 97, 99%. So at that point, the model has now, you know, figured out, okay, this is very unusual, and we need to flag this as fraudulent transactions. And then in real time, obviously, the credit card provider could step in and just block this credit card for further transactions. All right. God, I talked so fast. I hope this all made sense to you. There is a accompanying block for this solution. So Let me post this in the chat as well. So this blog, in very much more detail than I just did, describes the whole use case. You see the architecture here again. It's a great blog written by some of my colleagues. Absolutely love this one. And then just a little bit more on a high level, this blog also very useful, especially when I talk to customers who for the first time hear about Feature Store. These are, you know, some of the most asked questions from our customers, like why actually do we need a Feature Store? That's also where I copied the statistic out of here, and it just tells you a little bit more about, like, you know, why is it actually important to have a Feature Store when I could just use S3 or DynamoDB? Reducing training serving skew, also a very big topic, which we're going to address with the Feature Store, but obviously couldn't go much deeper into it now. All right. I hope you all took something out of that. If not, go back to the blogs, go back to the repos, and explore further.
Hey, Heiko, a couple follow-up questions. So the that first diagram that you show, there was a little bit of confusion as to what the arrows represent. And
fair enough. So basically, the arrows visualize the data flow. So let's go straight into the bottom half of this diagram where it says live transactions. I'm going to zoom in a little bit further. So live transactions. So this is where a transaction happens, and then the data flows into the Kinesis stream. That's what we did in the notebook that I just showed. We created these transactions and fed them into the stream. And then the data will be aggregated in a streaming aggregation within Kinesis via Kinesis Data Analytics. And then the data flows into a Lambda function. And the Lambda function then pushes the data into the online feature store. Another Lambda function here at 0.5 will then retrieve the data from the feature store. And it will make an inference using the model that we've deployed earlier. The model then, with this arrow, gives us back a risk score. And then at the end, we can do something with that result. Does that make sense? Hope it does.
I think so. And another quick question, then it's going to be top of the hour, but someone asked the question, you know, could I use the real-time feature store for my training activity? And I was curious your thoughts, because my my sort of instant response is no, that's not the most cost-effective way, but being edge case pushers that we all are, you know, very curious.
No, I think you're spot on. I mean, you can, but I don't see any reason why you would. So the online feature store basically is, you can think of it as a snapshot of your latest feature values. You have all the feature values, including the latest, also in your S3 bucket in the offline store. So the underlying technology to store your data in the offline store is actually S3. You have all the data already in Parquet files readily available in S3. So training your model from that is much easier and much more cost effective. But I mean, you can, but the read APIs for the online feature store are much more expensive than than just using the data that's already available in the offline store. Hope that answers the question.
Yeah, does the real-time feature store API have batch retrieval functions?
Yes, it does. Yes, because there is an ingest API where you can retrieve the data directly from the online feature store into a pandas data frame. Yes.
Oh, interesting. Oh, okay, cool. Okay, great. One final fun question. This is for, let's see if Manny's still on. Yeah, Manny, what is your favorite Valentine's Day movie? And then same question to you, Heiko, but yeah, we'll let Manny go first.
Can you repeat the question? Which is my favorite?
Favorite Valentine's Day movie? Yeah, Ancha, same question for you as well.
My favorite movie is P.S. I Love You. That's my favorite Valentine, like a movie that I would like to watch on a Valentine's Day.
Gotcha. Yeah, Ancha, how about you? Yeah, what's your favorite Valentine's Day movie?
Oh, that's going to be a cheesy one, I guess. It's probably The Notebook.
Oh no. Okay. Still haven't seen that one. Yeah, Heiko, how about you?
So I gotta go with a very British cheesy one, and it's actually more for Christmas, but I still love it. It's Love Actually.
Oh yeah.
That's a nice one, yeah.
Yeah.
Is that with Hugh Grant, maybe?
It is with Hugh Grant, yeah. Mm.
Gotcha.
Oh, another one. No, all About Time. If you haven't seen About Time, it's one of the best rom-coms ever out there. It's with Bill Nighy, which is a great British actor. Yeah, let me post that in here. About Time. It's brilliant. It's funny, witty.
So mine's called Valentine's Day. And it's been airing nonstop here in the US for the last couple days. Okay, great. Ancha posted the link to the Slack channel. If you'd like to continue talking, that's a public-facing Slack channel. And speakers, Mani, Heiko, thank you so much for putting this together. This was awesome.
Absolutely. Pleasure.
Great, and we'll be posting the video for today. And I realized I didn't post the one from last month, so I will post that one as well too. And the link is coming here. It's also on the website. Great, thank you so much, and see everyone next month.
Thanks, everyone. Cheers. Bye.
Yeah.
Thanks all. Bye-bye.
Bye-bye. Thank you.